Let's envision a busy airport where unauthorized drone activity and unauthorized users of RF spectrum can pose serious risks to flight safety and network performance. Booz Allen's radio AI-enabled spectrum sensing system can detect and classify this in-band interference, even if it is overlapping normal commercial and aviation transmissions. Critical capabilities like video feeds or ISAC can be degraded due to the presence of jammers or interference from unauthorized users. Radio spectrum sensing is a GPU-enabled distributed application, or DApp, that continuously monitors the RF environment, allowing mobile network operators and private 5G providers to respond to threats in real time by alerting security teams or by initiating automated mitigations like physical resource block or PRB blanking to preserve network integrity. Here we have a laptop that is using a software-defined radio, SDR, to transmit signals which interfere with the 5G UE uplink inside the shielded box or test chamber. In this setup, one or more users are sending uplink data with a UE, and an SDR creates in-band interference, which radio senses. When an uplink message transmission fails, radio then detects if interference is present, and the output is then shared into the spectrum sensing capability. Next, we will look at the radio DApp view. This visualization helps us to quickly identify and address any issues. The radio AI model provides details about an interfering signal, such as the interfering waveform type, percentage confidence level for that prediction, and more. This view indicates interference detection. You will see a grid of network resources, where green signifies normal operation, gray is unused spectrum, and orange, red, or purple indicates the presence of a jammer. This visual representation helps us quickly identify and address any issues. When a user activates the jammer by selecting a waveform type and transmit duration, a command is sent to an SDR connected to the RF test chamber, with the radio unit and UE inside to inject interference into the spectrum. When the interference is detected by the radio spectrum sensing application, the time and frequency cells on the plot will be color-coded orange, red, or purple, depending on the type of interference detected. This allows network operators to quickly determine if degraded network performance is due to unauthorized users, jammers, or normal conditions. Here we can see the radio spectrum sensing application correctly identifying the different types of interference that were transmitted at 3.75 GHz, with DSSS in orange, QPSK in red, and 64 QAM in purple. The radio spectrum sensing application also has the ability to visualize the real-time frontal IQ data from NVIDIA's aerial framework, which is used by the DApp to identify interference. The top plots show the spectrogram view of data at each antenna. The middle plots show the time series IQ data, and the bottom plots show the PSD, or power spectral density, where you can see the interfering signal in the center of the spectrum, which is stronger than the 5G uplink. Radio enables mobile network operators to understand if users are experiencing degraded performance on a network due to normal conditions, or if malicious actors are causing degraded network performance, so that MNOs can appropriately respond.